So your test is next class, emailed out a YouTube tutorial. Number 1, suppose this mass begins from rest, probably mentally or actually, I would underline from rest. That's a habit I have from good old Physics 11. M1 is 2.2 kilograms, blah, 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 blah. We want to find the time that it would take to slide down the slope. Okay. So I said to myself, they want me to find time. VI is 0. D is 4.8. I said, you know, if I could figure out the acceleration, I think I could use T equals 2 times D over A square root. I used D equals VI, T plus a half AT squared. VI was 0, and I got the T by itself because I can. Okay, so even though this question says find time, I'm going to spend most of my time finding A, I think. This is a job for a free body diagram. So I said, what are the forces acting on it? Get the obvious one. There is M1G. Normally I would just use mg, but since they used m1, I'll use m1. Components, m1g perpendicular, m1g parallel, color, 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 normal force, and it's sliding down. It does have a mu sitting there, so friction is going to be pointing uphill. Okay, I got my setup. I'm going to make the assumption that this is winning. Now, if I wasn't sure, I could really quickly calculate M1G parallel, M1G 2 lines, sine, and I could calculate friction, mu times the normal force. I don't know the normal force. Oh, but look, 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 look. I don't know the force the same size as the normal force. But you know what? I'm lazy. I'm going to gamble that M1G parallel is winning, and if I get a negative acceleration, I'll know I just guessed wrong, and I'll tweak the question. Who's winning then? I'm going to say M1G parallel minus friction equals M1A. I'm going to say M1G parallel minus mu M1G perpendicular equals MA. Now, I've already noticed that my M1s are going to cancel. I can cancel them out on this line, or I can cancel them out on the next line. For some reason, I usually cancel them out after I brought in the trig stuff. I don't know why, but I just do. So it's one of the few times I write extra stuff. Anyhow, I'm going to go M1G sine theta, 2 lines of sine, minus mu M1G of cos it is, equals M1A, and now I can go, yay, G 9.8 sine theta, Mr. Dueck, 53 minus 0.44 times 9.8 cos 53, and I'm going to cleverly put the A on this side now, A equals on that side, and I get an acceleration of 9.8 sine 53 minus 0.44 times 9.8 cos 53. Did y'all get an acceleration of 5.2316? Okay. And that, you know what, with the 0 right there, that's a nice place to round off. I'll carry a few extra sig figs because I'm going to use this value. So 5.2316. Do I need to call this negative at all? Am I slowing down or speeding up? I am speeding up because I decided gravity was a winner and I got a positive answer. If I was slowing down, if uphill was the winner and I knew I was slowing down, for example, or if I got a negative acceleration and I said I picked the wrong winner and I have to rework the question, then for the kinematic stuff, if I'm slowing down, I would let the acceleration be negative. I'd probably catch it because I'd get weird answers along the way. I've taught you, I hope, to always look at your calculator and ask, does this answer make sense? So I probably would catch it. All right, time equals the square root of 2 times d over a. Time equals the square root of, what was d? 4.8. All over 5.2316, although I'm going to use my answer button. 2 times 4.8 divided by answer button, square root of that. Do you get 1.35 seconds? I would take probably 1.4 seconds. I would probably take 1.34. Maybe if you use the 5.2316 instead of your answer button, you might get a tiny bit below that. I don't know. But I'm going to go 1.35 seconds. Now, if you got that, 4 out of 4. Otherwise, I would definitely give you a half mark if I saw that line right there. I would probably give you a half mark if I saw that line right there. I would give you a half mark if I saw that right there. I would give you a half mark if I saw that right there. What am I up to right now? 2 marks. I would give you a half mark for the numbers, 2.5. I would give you a half mark for the answer, that's 3.5. You know, I'd probably give you a half mark for the numbers here too, something like that. But if you got the right answer, 4 out of 4. Is it 4 out of 4, yeah? Okay. Number 2. Accelerating downwards. Oh, they even put the accelerations in the picture for me. That was quite clever of them. And the rope tension is 35.4. Oh. I think in the question we did in the homework, I gave you the acceleration. Here I gave you the tension, but it's going to be the same procedure. You want me to find mystery mass M1? Oh, so first of all, it wants me to find the acceleration. Okay, then I'm going to use M2. What are the forces acting on it? Get the obvious one. I have M2G. I have tension, and because it's accelerating down, I know M2G minus tension equals M2A. I'm going to do the swappy dance. I'm going to get M2G minus M2A equals tension. Let's keep this all on one screen, Mr. Dueck. It's going to be M2 5. Sorry, I'm getting tension by itself, Mr. Dueck. I'm getting A by itself. Why am I doing the swappy dance? Katie was going, Mr. Dueck, what are you going to do? You're just going to let me go further and then call me out for your free candy, but I caught it this time. Ha ha. Sorry, I'm going to get the A by itself, Mr. Dueck. Wow. A is going to be M2G minus tension all over M2. A is going to be M2. Let's try that again, Mr. Dueck. 5.9, G 9.8 minus 35.4. That's a terrible looking 5. All over 5.9. Sheesh. Bracket. 5.9 times 9.8 minus 35.4, close off the top, divided by 5.9. Did you get an acceleration of 3.8? Did you get how hard it was to make that work out evenly? Normally I don't care, but I wanted you to get a nice answer. 3.8 meters per second squared. If you got that, 2 out of 2. Otherwise, I notice I wrote 1, 2, 3, 4 lines. Probably a half mark for each line is what I would do in my handy-dandy marking scheme. Now, here in this question, I specifically asked you to find the acceleration, and then I said find the mystery mass. Mateo, I would have no problem just asking you to find the mystery mass on a test and expecting you to realize I can't. I got to find something else first. I either have to find the tension first or I have to find the acceleration first. Okay? So I would have no problem doing that. But I would also have no problem breaking it up into chunks. Find mystery mass M1. Okay. This is a job for a free body diagram for M1. On M1, I'm going to have M1G tension. I should point out on your test, there will be a written question where 4 marks, I ask you to draw a free body diagram. Okay? It'll be a fairly intense one. Do components go on your free body diagram? Technically not. Or if you put the components on, you shouldn't put the main force on. Now, if you put the components on with dotted lines, I'll live with it, but I would have a concern if you put the components on with solid lines and the original force, because you've inadvertently drawn the same force twice. So I will give you a free body diagram to draw for marks as well. And there's definitely going to be something to do with a ramp. There's definitely going to be an Atwood machine, but physics 11, this is too easy. So Atwood machine, find the mass. And if I look at M1 then, I think I have tension minus M1G equals M1A. What am I trying to find? M1. How many M1s do I have? 2. How many do I prefer? 1. Let's get them to the same side. Still have 2 M1s. It'd be cool if there was a grade 9 mathematical operation that I could pull out of my back pocket and somehow convert this from 2 into 1. And there is. What? Factor, you say. I can write this as M1A plus G, or G plus A. For what it's worth, usually you'll end up with either a G plus A or a G minus A, but I've never bothered memorizing which one is which. It's just too easy to derive it each time, and so I've never tried to file and store all these away. So M1 is going to be tension divided by A plus G. M1 is going to be, what was tension? 35.4 divided by 3.8 plus 9.8. 35.4 divided by 3.8 plus 9.8. Did you get 2.6 kilograms? If you got that, 2 out of 2. Otherwise, I'd probably give you a half mark if I saw that. I'd probably give you a half mark if I saw that you'd recognize we needed to factor. I'd give you a half mark for that equation and a half mark for the answer. If you got the acceleration wrong, but you went 35.4 divided by your acceleration plus 9.8, I would give you 2 out of 2 for part B, right? Oh yeah, turn the page. M. Yes? If you're on flat level ground, scale's going to read big M. Although it's displaying big M, that's not really what a scale measures. A scale measures normal force, but you would read your normal mass. Now if we roll down a ramp which is inclined at an angle theta, what will the scale read? More than M, less than M, or M? Now, there's several ways you could answer this. If you used the starting at 90 degrees, going to 0 degrees, looking at the extremes argument, and you said something like, well, look, if theta was 90 degrees, the scale would read 0, and I've just finished saying that when theta is 0 degrees, when we're flat, it reads big M, so we're going from 0 to big M, or from big M, from 0 to big M. Sorry, let's try that again. From big M to 0, starting at 0 degrees, and you said something like that, I'd give you full marks. If you drew a lovely free body diagram, if you said something like, hey, for what it's worth, mg normal force, if you said something like scale reads Fn, and then you said that Fn was equal to mg perpendicular, which is mg cos, and you said something like, I know that cosine is always a decimal, and so it's always going to make this smaller. If you said something like mg cos theta will always be less than mg, except when mg theta is 0, because then cosine of 0 is 1. I would take something like that. So if you feel that you've done a convincing proof, I'm good with that. If you want me to look at yours later on and lawyer with me, I'm fine with that as well. I suspect a lot of you looked at the extreme values. I'd like to think some of you went with a lovely trig answer. Now, if any of you said, well, Mr. Dueck, the cosine graph looks like that, and so if I look at it over the domain between 0 and 9, you would make my heart sing, and I would say, oh, I like that, because there's a lovely graphical answer here too, but I don't think you guys have done the cos graph yet, have you? Oh, the ignorance that you possess that you just, oh, we're getting there. Number 4, find the acceleration. This is a job for a free body diagram. M1G, tension, M2G, components, M2G perpendicular, m2g parallel. Normal force number 2 to go with mass number 2, tension. No friction. Okay. By the way, if I add that, the 3 red lines would be the free body diagram for this. The dotted lines, if I just said draw the free body diagram, you could leave off. But if you did put them on because you like to, just make sure they're dotted. That's physics speak for I've broken another force up into these. This isn't yet a separate force acting on here. Who's winning? That's a good question. I'm not sure. I'm going to have to do a quick comparison. 11 times 9.8 is that. 10.5 times... Oh, you know what? Wait a minute. I don't need to do a comparison. The fact that this is larger, it's going to be winning, because even if this was hanging straight down and I had the maximum force, 10.5 times 9.8 is less than 11 times 9.8. So I'm pretty sure, I know that that's winning. Do I have to always have a larger mass here for this to be sliding? Or could this also slide with a smaller mass? Yeah? Oh, okay. It's going to be M1G minus tension plus tension minus M2G parallel. That equals M all A. Got to like that. So A is going to be M1 plus M2, and this is going to be M1G minus M2G. 2 lines is sine. Okay. M1, 11 times 9.8 minus M2, 10.5 times 9.8, sine 58, all over 11 plus 10.5. A equals bracket 11 times 9.8 minus 10.5 times 9.8 sine 58. Now, if I have guessed wrong with my winner, I'll know if I get a negative acceleration. Oh, I got a positive acceleration. Did you get an acceleration of 0.955? Or am I wrong? Yeah, 0.955 meters per second squared. 4 lines, so I would probably go something like half mark for that line, half mark for that line, half mark for that line, and a half mark for that line. I figured you needed a story because Sean was reading something or other. Here we go. So there's that. Find the tension. I'm going to use mass 1. That's going to be much nicer. So it's going to be M1G minus tension equals M1A. Here I'll do the swappy dance. Yay. Knew I had it coming somewhere. So tension is going to be M1G plus M1A. It's going to be M1 10.5? No, 11, Mr. Dueck. 11 times 9.8. Sorry? It is minus. You're right. I'm slumping here. 11 times 9.8 minus 11 times 0.955, although I'm going to use my answer button here. It's going to be 11 times 9.8 minus 11 times answer button. Do you all get a tension of 97.3 newtons? People nodding? No? Yeah? Okay. Two out of 2 if you got that. Otherwise, I would probably go half mark for that, half mark for that, half mark for the numbers, and a half mark for the answer. Yeah. If I gave you, on the test, if I gave you an Atwood Machine / ramp question that looked like this, with a pulley there, and a theta 1, let's say, and a theta 2, I'm not going to put one like that on the written, because if you can handle one angle, you can handle two. I might feel comfy putting that as a nasty multiple choice, maybe, but I'm trying to remember. I've got several different versions of the test. I think maybe on one of them I might have put 2 angles as a nasty multiple choice, but I didn't put it as a written. With the shorter classes, I have to be a bit more careful, because sometimes I fall into the trap of, oh, this is so neat, and I love doing the math, but it's just time-consuming. It's not as much as I'm assessing anything new. If you can do the components and MG parallel and perpendicular for one angle, you can probably handle it for 2 angles. Fine tension, you could handle it for the uglier angle or the uglier mass. Remain stationary. So which way is M2 sliding? Up the ramp? So which way is friction pointing then? So I'm going to add that in black for part C. I would have this. And so what I would now have as an equation is M1G minus tension plus tension minus M2G parallel and minus friction. That equals 0. I would still cancel out that. It's going to be M1G minus M2G sine theta minus mu times the normal force. I don't know the normal force. Oh, but look. Have I messed up? No. I'm good, I think. I don't know the normal force. Oh, but look. It's going to be M2G perpendicular. Did I say perpendicular? Of course I did. So now I'm going to get the mu by itself. I think what I would do, my own math nerdiness, I hate negatives in front of the thing that I'm trying to find. So I would plus this whole mess to that side and then divide by M2G cos. I don't know if I'm going to be able to fit all that in. So I think I'm going to end up just saying mu equals M1G minus M2G sine theta. Oh, wait a minute. Katie, were you saying that I could cancel out gravity? Is that what you were saying? Well, that's easier. Because there is I divide by G there too. So yeah, the G's cancel strangely enough for this one as well. So that makes it a little nicer. Then I'm going to have M1 minus M2 sine, what was the angle? 58. And I think it would be all divided by M2 cos theta. Wow. M1 was 11 minus 10.5 sine 58. I don't know why I put a theta in the bottom there. Minus all over 10.5 cos 58. Does this look right, humans? I'm not sure now. Bracket 11 minus 10.5 times sine 58 divided by bracket 10.5 times cos 58. Do you get a mu of 0.377? Yeah. That one had some teeth. Units from you? There are none. Hannah, you going to make it? Okay, just making sure. I can get you a lower chair and get you a little lower down, maybe a little lower table if you want. It's okay. I would give you a half mark if I saw that. I would give you a half mark if I saw that. If you didn't cancel out the G's, I'm fine with that. Half mark. Half mark. I don't know if I've done one quite like this with you, but to me, this is fair game. As far as I'm concerned, David's going to put his phone away. As far as I'm concerned, I can ask you any question going forwards or backwards, and we can get whatever we need to by itself. This is a job for a free body diagram. They want me to find mu, so I said, okay. mg components, mg perpendicular, mg parallel, normal force, and I guess there's some friction acting up the hill. I said, who's winning? Well, mg parallel. Who's losing? Friction. What does that equal? ma. What if we were skiing up the hill, by the way? Which way would friction be pointing? And so what would my equation be? It would be mg parallel plus friction equals ma. Mg parallel minus mu times the normal force. I don't know the normal force. Oh, but look. I know another force the same size as the normal force. Mg perpendicular equals ma. Turns out grown-ups and little kids can ski together because the mass cancels. Otherwise, grown-ups and little kids couldn't ski together without the grown-up always having, or the kid, I guess, always having to make an adjustment of their speed all the time and change their ski angle and speed up or slow down or drag their poles or do something. But that's not the case. Question wants me to get the mu. Well, let's bring in the trig, and then I'll get the mu by itself. So I have g, two lines is sine minus mu g perpendicular of cos it is. That equals a. I decided to do the swappy dance. And also right around here I started to get a bit of a because I was looking at all my other things and I said, I don't think I know a. And I'm going to need the acceleration to do this. But I'm committed. I'll get the mu by itself at least. So I said g sine theta minus a equals mu g cos theta. Looks like the g doesn't cancel here. Skiing on the moon would be different from skiing on the earth, even if you were on the same hill. And I said, okay, mu is going to be g sine theta minus a all over g cos theta. And here's where I said, I guess they kind of want me to find a. Well, from rest, and there's a VF of 20, and there's a time of 8. Oh! I said I can go A equals VF minus VI over T. I can go 20 minus 0 over 8. I even said I think I can do that in my head because it's 20 divided by 8, divided by 4, divided by 4. It's going to be 5 divided by 2. Is A 2.5? And I can bring that into here. Cool. It's going to be 9.8 sine, what the heck was theta? 16? Minus 2.5 all over 9.8 cos 16. What's mu? I don't know. What's mu with you? Here's what we end up getting. We're going to get 9.8 sine 16 minus 2.5, close off the top, divided by bracket 9.8 cos 16. Did you get 0.021? And that seems about right for snow. Should be fairly small. 0.213 if I go to 3 sig figs, or 2.13 times 10 to the negative 2. And no units, because it's a coefficient of friction. If you got that, I would give you 4 out of 4. On the test, by the way, your written questions are almost always going to be worth 7 marks, so this would be a good 7-mark question. Otherwise, I would probably do something like this. Half mark if I saw that, a half mark for finding the acceleration. Then I have 3 more marks to play with. 1, 2, there's 1 mark, sorry. Probably something like that. Last one. Oh, here's an example of a free body diagram. Ooh, in friction prevents it from moving. Okay. It says, draw a free body diagram showing the forces acting on the bale of hay. I'm going to draw a free body diagram here, and I'm also probably going to label my forces up here. So what are the forces acting on it? Get the obvious one. I have mg. There is definitely an F applied. Is the normal force going to be bigger or smaller or the same size as mg in this situation? Smaller. So here's what I would look for. If you're marking your own, I'm looking for a normal force that is definitely smaller, not the same size, and not larger. Okay? What else? Friction. Why must that be wrong? And why must that be wrong? How long am I going to draw friction exactly? I'm going to draw friction exactly as long as the x component, because those are canceling out. Now, I'm not going to be fussy on that one. I'm going to be fussy on the normal force being shorter. If you didn't draw friction exactly the same size as Fx, I won't take marks off. How many red lines did I draw? How many marks is this worth? Half mark per line? Would make sense. Okay. I'm going to now label it up here as well. I have mg, short little normal force. I have F applied, components, there's Fx, there's Fy, friction. Okay. Calculate the friction force on the bale. My first thought was to go, oh, Dueck, this is so easy. Friction equals mu times the normal force. Why does that strategy come and kick me in the face? No mu. Mr. Dueck, you sneaky person, you. And so, because we're at rest, or I could have also said constant speed, because A is 0, that has to be true. And so this question that stumped me for a while, I went, oh, and Fx is going to be hypotenuse, adjacent, opposite, of course it is. I said friction is going to be the applied force times the cosine of theta. If I plug in numbers, friction is going to be F applied 140 cos 28. And I got, you got 123.6. I'll call it 124, but I'm going to store this on my calculator. In fact, I think I'm going to write 123.61. because that's 5 sig figs worth, and then I'll say 124 newtons. Is that correct, folks? Yeah. I would also take 120 newtons. I take 2 sig figs, but I usually go to 3. Okay. Calculate the normal force. I don't know the normal force. Oh, but look. Everything down equals everything up. So I would say the normal force plus Fy equals mg. That means the normal force is going to be mg minus Fy. The normal force is going to be m. What was m? 55 times 9.8 minus Fy. I think Fy is going to be 140 sine 28. Do you get a normal force of 473.27? 473? What's mu? Huh. Oh, I forgot to do my part marks, by the way. I would go half mark, half mark, half mark, and I would go half mark, half mark, half mark, half mark. Well, I wrote this. Friction equals mu times the normal force. And then the light went on. I said, oh, mu equals friction divided by the normal force. Friction is 123.61. The normal force is 473.27. Okay. 123.61 divided by answer button. Do you get 0.261? 0.26 something? 1 mark for that. Okay. I would probably give you a half mark if I saw mu equals friction over normal force. I would give you a half mark for the answer. If you got B or C incorrect, but you successfully went your friction force divided by your normal force, I would give you the full mark for the last bit here. Can you give yourself a lovely score out of 29, please? If you need to lawyer with me,